Okay, this is the 3.6 extra examples from class on your notes. Let's look at the directions for this C and D that we didn't do. It says to find the standard equation of the parabola with the given points. Okay, if you're given a vertex and a point, the best way to get this in standard form, which remember is ax squared plus bx equals c, is to start it out in the vertex form that we learned. Now remember, vertex form was f of x equals a times x minus h squared plus k. And so for us, h and k are the vertex, and x and f of x would be the second point. So we can plug in what we know and solve for a, then we'll have enough information to get an equation. So for this first one, this would be -3 equals a times 2 is x minus 0 for h squared plus 5. I would move the 5 over, so this would make this -8 equals a times 2 squared would be 4. Divide by 4, and we get a equals -2. Your next job is to write that in vertex form with f of x and x just being letters, and a, h, and k would all be numbers. So this would be -2 parentheses x minus 0. I'm going to write that right now, but then I'm going to reduce it, and then this would be plus 5 at the end. A better way of writing that would just be -2 times x squared plus 5. And since that's just a singular term, getting this one in standard form is actually pretty easy. You just drop the parentheses and write it as x squared plus 5. So that would be the standard form for that equation. For part D, we have the same kind of setup, except this time they give us an x-intercept as a point. So I'm going to write that as an ordered pair. So here's my h and my k, and this would be my x and my f of x. So we plug that into the vertex formula. So this would be 0 equals, we don't know a yet, and then we have x is -4 minus the h, which is also 4, squared plus the -7. I would move the 7 over, so I'd be adding that. This would be -8 squared. So this is 7 equals a times 64. And so a is 7 over 64. So when I write that into vertex form, that would be 7 over 64. And then we would have our x minus 4 squared minus 7, because it's plus -7, but that's just minus 7. Now that's in vertex form. We want this in standard, so we need to FOIL this out first. This is going to be nasty because of the fractions. So this would be x squared minus 4x minus 4x. That'd be minus 8x. And -4 times -4 is positive 16. We need to multiply through by the 7 over 64. So that'd be 7 over 64 x squared. The -8 and the 64 can reduce. That would actually be minus 7 over 8x, because you'd get the 8 reduces down with the 64 and just leaves you with an 8 on the bottom. And then similarly with 16, 16 I believe goes into 64, doesn't it? 64, nope, not 90. 64 divided by 16, is it 4 times? Yes. So this would be, so 16 and 64 would reduce and leave you with a 4 in the denominator, so it'd be plus 7 over 4. And this guy also needs to be combined with this. I'm going to go ahead and get that new common denominator, times this by top and bottom by 4 to combine with this fraction. That would be 28 over 4. So my final answer would be 7 over 64 x squared minus 7 over 8x, and that would be 7 minus 28, so that'd be -21 over 4. And that would be in standard form for the parabola. Okay, the next thing that we need to go through is a couple more of the graphing problems. So remember we talked about how when you're graphing a quadratic, there's going to be a couple things that I'm going to ask you to do on the test to list out. I first of all want to know if the parabola opens up or down. I want to know the vertex. And remember, in this case, we wouldn't do the completing the square method of turning it into the vertex. We would do negative b over 2a to find the x value for that. We want to know the x-intercepts if they have any, and y-intercept. And we want to know something called the axis of symmetry, which is the vertical line through the vertex that cuts the parabola in half. First of all, to know if it opens up or down, look at the number in front of x squared. If it's positive, it's a parabola that opens up. If this was a negative, it would be a parabola that's upside down. My vertex I find by doing negative b over 2a. That is negative 7 over 12. So sometimes it's not a pretty number. I need to plug that into the function to find the y value. So 6 times negative 7 over 12 squared plus 7 times negative 7 over 12 minus 24. This would be 6 times 49 over 144, because I have to square top and bottom, plus a negative 49 over 12 minus 24. 6 should go into 144. It goes in 24 times. So this is 49 over 24, if we reduce that fraction right there. I'm going to go ahead and double this denominator and double this top so that I can then add those together. So 49 times 2 is 98, so this would be negative 98 over 24. And I'm going to go ahead and get this to have a common denominator as well. 24 times itself is 576, so minus 576 over 24. And I just need to now subtract across the top. So 49 minus 98 minus 576 is negative 625 over 24. I would obviously check if that reduces, but I believe it doesn't. Now, when you're going to go graph this, you're obviously going to turn this into decimals because nobody wants to graph those as fractions, but it's good to know what they look like. So I'm going to go ahead and figure out what they, the fractions I already know, but I want to know the decimals. So this is going to be way off our grid. This point is, let's see, approximately the vertex is negative 26 for y, so we're rounding. Essentially, it's a little bit over. It's like negative 26.04, and 7 divided by 12, and it's also going to be negative, is negative 0.58. So we have to think that this guy is going to be way on down here. So here's like negative 12, negative 14, blah, 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 blah. That point's going to be way down there. So let's actually draw this a little bit lower. Negative 16, negative 18, negative 20, negative 22, negative 24. And I did not give you enough space to do this graph. So bad numbers on our choice here. Let's just make sure we didn't make any silly mistakes though. So negative b over 2a is definitely negative 7 over 2 times 6, which is negative 7/12, and I believe that should come out correct. Now, if you're trying to find your x-intercepts, this guy does not factor, I don't think. So even if I don't want to factor it, like if I'm just like, I don't even want to try to factor it, you can always find your x-intercepts by, or if they exist, by trying the quadratic formula. So negative b plus or minus the square root, b squared would be 49 minus 4ac all over 2a. So this one would have, let's see, 4 times 6 times 24 is 576, and that is all positive because it's a negative times a negative, plus the 49. So that's 625. Oh, maybe this did factor. So that's negative 7 plus or minus the square root of 625 on top, all over 12 on the bottom. So that's negative 7 plus square root of 625 over 12, and negative 7 minus square root of 625 over 12. Now, does 625 actually factor? I know it's divisible by 25. Yeah, it's 25 times 25. So this is just this is a perfect square. So this would have factored if I wanted to spend the time factoring it. So this is actually just plus 25 and minus 25. So 25 minus 7 would be 18. And then we would divide that by 12. So one of my x-intercepts is 9 over 6, and that reduces again. So that would be 3 over 2. And then my other x-intercept is negative 32 over 12. And those are both divisible by 4. So that would be negative 8 thirds and 0. Your y-intercept, remember, is just the constant, because if you plug 0 in for everything else, so it's negative 24. And the axis of symmetry is just a vertical line through your x-coordinate of your vertex. Now this one's obviously not a good one to graph because it's going to go way off the grid, but 0, negative 24 is my y-intercept, and at negative 0.58, which is right around here, kind of if I'm going down, I go just a little bit below negative 26 there. And then we have just these tiny x-intercepts of 1.5, and negative 8 thirds is negative 2 and 2 thirds. So negative 2 and 2 thirds is my other x-intercept. So notice that, wait, that doesn't make sense. Did I get my signs backwards? Oh, no, I have this graphed backwards, sorry. Negative 5.8, negative 26 is on this side. Sorry, I was like, something doesn't match up, because these need to be equal distance from the vertex. So this guy is the most uninteresting parabola because he's not graphing nice here. And we would never give you something like this on the test. This is just to show you kind of how extreme some of the numbers can get. We give you something that is nice and factors. Okay, so let's look at D. In this one, we're going to do the same steps. So opens up or down. This one would open down because it has a negative up front. And then I want to know the vertex. So I do negative b, which would actually be positive 6 over 2a. That is 6 over negative 6 or negative 1. So that's a nicer starting point. Plug negative 1 into the function to find your y value for the vertex. This would be 1, but times negative 3 is negative 3. That's a plus 6 and a minus 6, so this is just negative 3. Do we have any x-intercepts? Well, we can try to factor this. So if you think about setting it equal to, so this is for my x-intercepts. Set the whole function equal to 0. I'm going to try to pull out a negative 3. That would leave me with x squared plus 2x plus 2. That does not factor because factors of 2 are 2 and 1, and there's no way to make 2 with that. So we would do quadratic formula, so negative b, and you can ignore the negative 3 if it's pulled out as a GCF. You can use 1, 2, and 2 as your a, b, and c. So negative 2 plus or minus the square root of b squared, which would be 4, minus 4ac all over 2a. Uh-oh, I'm getting a negative underneath my radical. That means this is imaginary. If you have an imaginary solution to your x-intercept, in other words, you don't have x-intercepts, this would be the case where you either hover above or below the x-axis and never cross it. The y-intercept is just the constant, so that would be 0, negative 6. The axis of symmetry would be the vertex x, so x equals negative 1. So negative 1, negative 3, and then 0, negative 6, and that kind of makes sense because they're now, this is over 1, down 4, so over 1, down 4, the other direction would be my other point since that guy's my vertex right there. And notice this never crosses the x-axis because it's going down and the vertex is already below the x-axis. And then I think there is one more graph, yes. So this one, does it open up or down? Well, it has a positive in front of the x squared, so that means we're going to be opening up. We have a vertex of negative b over 2a. That would be just 4 over 4, so that's positive 1. Plug that in to find the y value. That is 2 minus 4 minus 11. That is negative 13. So we'll have to add some lines here. 11, 12, 13. The x-intercepts, let's see, does this factor? I don't believe so, but let's just do quadratic formula because sometimes that's quicker. Negative b plus or minus square root. Negative 4 squared would be 16 minus 4ac all over 2a. That would be 8, and then negative 8 times negative 11 would be positive 88. So 4 plus or minus 16 plus 88 over 4. 16 plus 88 is 104. So 4 plus or minus square root of 104 over 4. Reduce, I believe 104 should be divisible by 4. Yeah. So this is actually 4 plus or minus 2 on the square root of 26 over 4. And we can reduce the 4, 2, and 4. This would be 2 plus or minus 26 over 2. So I have two x-intercepts. One is 2 minus square root of 26 over 2, comma 0. The other one is 2 plus square root of 26 over 2, comma 0. Obviously, when you graph these, you want the decimal approximation. So 26, take the square root, make it negative, and then add 2 to that, and then divide it by 2. So my first x-intercept's about negative 1.5. This one we will do square root of 26 and add it to the 2 and then divide it by 2. So that's about 3.5, which makes sense because that is 2.5 below 1 and that is 2.5 above 1. They should be equally spaced around the vertex. My y-intercept is 0, negative 11 because that's the constant. And my axis of symmetry is the vertex. X equals 1 is the vertical line. So 0, negative 11, 1, negative 13, it's down there, and then about negative 1.5 and about 3.5 are my two x-intercepts. And then I just draw my parabola through all my points. And that is the end of section 3.6.